The fundamental idea is that we want to use a variable u and substitute something to be u. And so in this particular case, we're going to say u equals 5x plus 6. Why do we want to do that? Well, if we did that, then the thing inside the integral would just be u to the fifth, and that's super easy to integrate, right? Right, that's just 1/6 u to the sixth. So we want to do that, but the problem is we still have this dx here. So we have to figure out what dx is. And the way we do that is we take what u is, and then we take the derivative of u. So we have to calculate du dx. So what is du dx? 5, good. It's just a derivative. And then the trick is to figure out, to isolate this dx. We're going to pretend like it's a fraction. And so what we're going to do is move the dx to the right side. So du equals 5 dx, which means that dx equals 1/5 du. Okay, so the step is figure out what u is, make a substitution, u equals something, then take the derivative, so differentiate, and then isolate dx. And then once we've isolated dx, we can now make this substitution and put it into there. And so the next step would be to say, so 5x plus 6 to the fifth, that's u to the fifth. And then dx is equal to 1/5 du. And so this is going to be times 1/5 du. Make sense? Please, no electronics. Yes. Every day, Zara. You know, we wouldn't have to do this, but now we do. Okay. And then we're going to integrate this just by using u as the new variable. Okay, so we're just going to do this integral with u as our variable. So 1/5 can come to the outside of the integral. And then we have this integral. I assume we all know how to do this by now. So that's 1/5, and then u to the fifth. The integral of that is 1/6 u to the sixth, which is 1/30 times u to the sixth. Plus c. Yes, Daniel?
Does the snake just become like multiplication?
Snake?
The snake, dude. That's what you
The integral sign?
Yeah, but after you get rid of it and you take the anti-integral, it becomes a multiplication sign, right?
Sure, because 1/5 is being multiplied on the outside. Okay,
Is there more steps?
I'm not done. Please be quiet. The final step is then to plug in what I have for u back into the final expression. And so u is equal to 5x plus 6, which means that my final answer is 1/30 times 5x plus 6 to the sixth power plus c. Okay? And then let's go back and check to make sure that this is actually correct. So let's take the derivative of the integral that we've just found, and we should end up with our original expression up here. Okay? So let's check. What's the derivative of 1/30 times 5x plus 6 to the sixth power? Well, the six comes to the outside because that's our exponent. So it's 1/30 times 6 times 5x plus 6 to the fifth power. And then what else do we need to do? We need to multiply by 5, right?
Yeah.
Because we have chain rule. We're doing chain rule because we have a function inside the power of 6. So we need to multiply by the derivative of 5x plus 6, which is where this 5 comes from. And so the 6 and the 5 will cancel out with the 30. And I'm going to be left with 5x plus 6 to the fifth power, which is what I expect, right? That's the same as what I originally integrated. Okay, so that shows how integration by substitution effectively reverses chain rule. Any questions? Okay, I'll let you guys try 1A briefly, and then we'll discuss more soon.
We're doing
Be thou my vision.
We're still going to small.
Be thou my vision, Lord of my heart. I listen to hymns.
Should I wait to eat this food?
It's very old, yes.
Huh? Should I go up?
No electronics, please.
I know. Should I go get soy sauce? Should I go get salt?
I don't know how to help you with that,
I just asked you a question.
and I don't know how to answer them.
Did I go get soy sauce? Or
Any questions about 1A? Please do it.
no.
Please, no electronics, okay?
Yes.
Yes, and no 1 second electronics either.
Next TikTok video will go viral. Two or no? This is great.
I'm not Daniel, I only one.
It's okay. Thanks, Kevin. You're gonna win the lottery, Mom.
I know.
No, but that'll win your lottery.
Yeah.
Your uncle that's yeah.
Your next TikTok video will go viral.
But you should tell him to slime me one that already nice. Oh my days. How do you miss that?
You're the
The derivative of oh, yes. I did argue
Let me do this.
Hello?
Are we?
Are you guys finished with 1A?
Maybe just good practice.
So what's the substitution you want to make?
You going to
Not fair.
There's no quiz this week. I didn't even know you were taking it this week.
Stop. We're good. No, wait. 100?
100%?
Yeah.
No.
Mr. Nye, you have something.
Oh my God, dude, I would bring you an apple for every single day of the rest of the year. If you give me an 80 on a quiz, that's it. 80.
Why do I want an apple?
What do you want? Give you Adobe. Give you every Adobe product free for
We have Adobe Creative Cloud free as
Anything.
teachers.
free. When you leave Valley next year, I'll give it to you.
Mm.
I'm talking business right now.
What is Daniel last?
How do you know I'm leaving Valley next year? Did I say that?
Homie.
You said that you might be, I asked about, you see it. Yeah. Oh, either. I said, that's me.
Okay. Can you guys keep that on the down low?
Of course. If you give me an 80.
Oh, this is also on YouTube. I guess I shouldn't have said that. You got into UCSB?
Oh, yeah.
I don't know. Personally, I prefer California, so I would go SB.
Let's see if you got it.
I just.
UW. I don't know about that one. Depends on your major. I don't know anything about poli-sci. I had some friends UCSB poli-sci. I don't go to Starbucks.
You're definitely a pizza guy.
I don't drink coffee.
But Black Hole is probably good.
I think the last time I went to Starbucks, I got water. Water?
You have good water I think that just confirmed. Wait, let me say something. I think. I think.
Daphne, what math are you taking? Uh-huh. Yes. Algebra what? One? You want some math problems? Let me give you some math problems. Do you know quadratics?
I don't like how we. Yeah, respect your. I don't. Even Noah said he would be. Look, even though I'm being for the break, I. It's like fixing.
Yes.
Double check my answer for number one.
You need to re-plug in X, right? The final answer should be in terms of X.
Thank you.
Oh,
You like slide time?
okay.
You know slide time?
Huh? No, I just. I don't know. I was kicking the ball and my right leg just died.
Good. Like not, are they very able to do it? Everything we spoke to.
Okay, so here's the work for 1A. Hopefully you got the same thing. Any questions about 1A? I substituted u equals 2x plus 5.
Why is it 1/2? Should it be 1/7?
Nope, it's 1/2 because I need to make the substitution for dx as well. So I need to, from u, I need to calculate what du dx is, then isolate dx. Okay?
Dx is 2 dx.
Dx is 1/2 du. So make sure you have this 1/2 du here. That's really the critical part.
If you leave it out, you might.
Hmm? Done? Too easy?
I don't know.
Should I, where did you get 60 from?
Who says that and you say no or no? I just go away. Well, where's the 1/2 come from? I figured that one out, sure.
One wrong.
I mean, you know, it wasn't.
All right, let me continue. Please be quiet. Let me continue with one more example. What's C? Sine 5x.
Can we do B?
Okay, let me integrate cosine 3x.
They sent me to go.
Okay, this is my next example. Shh, please. So what is the substitution I should make? U equals U equals
Is this one from?
3x. No, it's my example. Okay, so once I find u, I'm going to calculate du dx. So what is du dx?
Oh.
Shh. Du dx is 3, which means that dx is equal to what? Yes, 1/3 du. Okay, so you want to differentiate first and then isolate dx, and that's what you want to plug into here. So you're just converting the integral into a different variable u. Okay, so cosine 3x is just cosine u, and dx is equal to 1/3 du. Okay, what's the integral of cosine u?
Wait, can you let me do it? Negative signs.
Positive sign. Okay, so this is my integral, 1/3 sine u plus c. And then my last step is to just to plug in what u originally was. So it's 1/3 sine 3x plus c. Any questions?
What question was that?
None of them.
Can we do B?
Let me do one more. Let me do two more challenging examples from the classwork. Can somebody give me an extra classwork?
No way.
Okay, let me do some hard ones like D and sure, I said I. Oh. So let me do D and then I. Okay. Shh. Let me do D. So sometimes you want to be very clever in how you choose a U. Okay, and that's the whole idea. Some U's will not be as helpful as other U's. And what you want to do is choose a U such that the derivative of U is also found within the integral. Okay, did you hear that? You want to choose a U such that the derivative of U is also in the integral. Because if you do that, things will cancel out very nicely. In this case, I'm going to choose U equals x squared plus 1. Why do I want that? Because I know the derivative of U will be 2 times x, and that will cancel out this x in front of here. Brock, you want to sit out a chair? Okay. Let me show you how things cancel out. So this looks very complicated, but if I make a good substitution, it will cancel out. So du dx is 2x, which means that dx is equal to what? Dx is equal to 1 over 2x du.
Wait, du is over dx is equal to 2x, and that because you.
I took the derivative of u, so that gives me 2x.
And the negative derivative, the inverse derivative is the 1 over 2x.
No, I'm just isolating dx. So if I show more steps, which I could,
So just be 1 over.
I'm bringing du dx to the right side. So du equals 2x dx, which means that dx equals 1 over 2x du. And then notice how if I plug in this dx, this 2x here is actually going to cancel out with this x. And so it gets rid of that complicating factor. That's why I wanted to choose that in the first place. Okay, so if I make this substitution, it's going to become x times u to the 4th times 1 over 2x du. And you guys see how the x cancels out?
Oh, yeah.
So you want to be very clever in how you do this and choose something that will help you cancel out things. And so this ends up being 1 over 2 u to the 4th du, which becomes 1/10 u to the 5th plus c. And that would be the final answer. Any questions?
It's a lot of like moving things around. It's not a lot of math.
Yes.
I'm kind of understanding it. Thanks for teaching.
So once you've done a lot of these, you will be able to tell which u you should choose to cancel things out.
Are we sent off now? So I think we're good.
No, I'm going to do I as well. Okay, let me do I very quickly. 3, 2, 1. Wait, what is I?
You actually.
It's pretty fun. Is this I?
Yes, yes.
Okay. I have a good memory. Okay, so what should I choose for you? Yes, good. We want to choose x squared because the derivative of x squared is also found here, and it will cancel out if we choose u as x squared.
Yeah, that's good.
Got it? So we're going to use u equals x squared. What is du? What is du dx?
2x.
Good, 2x. So once again, dx is equal to 1 over 2x du.
You don't like going steps on that.
Lazy. Okay, so we differentiate u first and then isolate dx, and then we just substitute those things back into the original thing.
Okay, so then.
Okay, so we're going to have x times secant squared u times dx, which is 1 over 2x du. And once again, the x is going to cancel out nicely there, which leaves us only with u. That's our goal, to only have u. And ideally, it should be also an easy integral, which it is. So the integral ends up being 1/2 secant squared u, and the integral of secant squared is tangent u. Right? Because the derivative of tangent is secant squared, which you need to know by heart. And so the final answer, I'm going to plug in what u originally was. So it's 1/2 tan x squared plus c. Okay, I'll do one more just for fun. Which one should I do? What is J? What is J?
Yeah. Yeah.
Look at James Knight.
I know what it is. Just one.
For me.
Okay, let me do J. Shh. Quiet, please. So J is the integral of tangent x dx. Do we know anything that gives us a derivative of tangent?
Yeah, secant squared.
We do not know anything.
Is that not it?
So we actually need to convert this to sine x cosine x, as I've indicated on the paper. Because the derivative of tangent is secant squared. So the integral of tangent, we don't know.
You can't do it backwards.
We are doing it backwards.
I mean, if you use secant squared x, you make it tan x.
No, what I'm saying is that the derivative of tangent is secant squared. So the integral of secant squared is tangent.
You can't do.
But we don't know we don't know the integral of tangent. Okay, what should I choose for you? What do you choose for you?
Sine x over cosine. Yeah.
You choose u equals cosine x. Okay, why do we choose u equals cosine x?
You know the answer.
It will cancel out the sine x. If you chose u equals sine x, nothing would cancel. Okay? Actually, it would end up working, but it's not as obvious. Okay, so what is the derivative of cosine? Negative sine x. And so we're going to have to rearrange things and isolate dx. And so that tells us that dx equals negative 1 over sine times du. So you guys see how if I plug in dx back into here, the sign will cancel out? Thank you. Okay, so it ends up being sine x over u, which is cosine. Sine x over cosine is sine x over u, times dx, which is negative 1 over sine x du. And so just as we wanted, the signs cancel out.
What about the tan?
And so this ends up becoming negative integral of 1 over u du. Which now that I realize we haven't actually learned how to do this integral. So I shouldn't have I shouldn't have assigned this.
That's right. Hey, Bam had 83 though. Bam had 83.
Yeah. I'll just tell you the answer.
Sounds great to me.
Whoa.
Whoa! Oh no!
Yeah. No. All that.
I don't usually do the classwork beforehand, so I don't know the answers. So misassigned.
For what?
Okay, I'll do one more as compensation. What is H? Okay, we can do H. Cosine sine cubed. Please be quiet. If you guys keep talking, I will not do H. So what is it again? I forgot it. All right, so what should I use? What should I make U? Sine.
Oh, see, okay.
Okay, so the hardest part of substitution is choosing the right U. And you have to have a good intuition by doing a lot of these. If we chose U equals cosine X, we would not be able to solve this.
Right. You just have to like guess it.
You have to know.
That's not the word.
Okay,
No.
all right. Okay, I'll tell you how you know. Okay, the idea is that you want to choose U such that U prime dx is found within the integral.
Give us the U.
No, that's the whole heart of the problem is to know U.
That's all right.
It's not random. You can know. That's what I'm saying.
I don't know you.
You want to choose U such that U prime times dx is in the integral. Please listen. Shh. You want to choose U such that U prime dx Hudson. You want to choose U such that U prime dx is in the integral. In this case, we choose U equals sine x because cosine x dx is in the integral. Right? If you didn't get that, it's your loss.
You
gave them to him.
All right, I'm stopping there. You guys can just do the rest.